Deploy a probabilistic large language model into a high-stakes environment without strict constraints, and the system loops. It hallucinates actions, drifts off topic, and multiplies its own errors. Educator Frank Coyle addresses this exact instability in his computer science lectures at UC Berkeley. His proposed engineering fix relies on a concept with deep philosophical roots, the ontology. Originally conceived by Aristotle as a way to categorize the nature of being, an ontology provides a structured map of reality. In modern software engineering, this translates into neurosymbolic AI. By explicitly defining permitted entities, relationships, and rules, developers place rigid, symbolic guardrails around the unpredictable neural networks of an LLM. This combination forces a chaotic agent to operate within a predefined logic. But treating these semantic guardrails as sufficient for deployment allows an unvalidated map to authorize autonomous decisions. To understand the risk, we have to audit the system through the Bridge360 Metatheory Model, an epistemic thermodynamic governance framework. Bridge360 identifies a severe paradox. An ontology does constrain local hallucinations. But when you give that rigid ontology direct control over an agent's real-world actions, you introduce a massive systemic threat. The model defines this as ontological sovereignty. It occurs the moment a highly limited, resource-bounded map of a specific domain is treated by the system as unquestioned universal reality. Embedding this ontology directly into an agent smuggles in a dangerous assumption of truth. The system bypasses standard validation, dictating what counts as evidence, what counts as an anomaly, and what is a legitimate response. By attempting to eliminate AI hallucination through these rigid, unyielding categories, engineers inadvertently grant the system unchecked authority to execute institutional actions based on a flawed, incomplete map. An ontology in an agentic system acts as a rigid epistemic regime, presupposing that the world can be perfectly partitioned into stable categories. This flowchart illustrates the operational pipeline. It begins with a small, highly compressed theoretical map, which the system immediately hardcodes into rigid data blocks, a process known as classification. Once established, these classifications feed directly forward into a mechanical process pipeline, or workflow. The data structure itself begins to dictate operational logic. That workflow then extends outward. Without waiting for human oversight or secondary validation, the system automatically triggers a physical institutional action based solely on the classification. The executed action inevitably alters the real-world environment. That altered environment then generates new data, which feeds back into the system and appears to confirm the validity of the original flawed map. Through this recursive loop, the ontology becomes performative. It ceases to merely describe the environment and begins to actively create the conditions it analyzes. The AI is no longer reading the world. It is forcing complex, fluid, real-world variables to conform to its own resource-bounded, biased categories, punishing anything that doesn't fit. This pipeline fails because the agentic information space is computationally intractable. Securing total, permanent closure over a fluid environment is mathematically impossible. We can prove this limit starting with Kurt Gödel's first incompleteness theorem. Gödel demonstrated that no sufficiently complex formal system can fully certify its own truths entirely from the inside. An enterprise ontology, no matter how detailed, will always encounter edge cases and anomalies it cannot resolve using its own internal logic. Alan Turing's halting problem introduces the next impenetrable structural barrier for these systems. Turing proved there is no general algorithmic procedure capable of predicting every downstream behavior of a complex system. Once an agent interacts with a live, reacting environment, its recursive actions cannot be entirely mapped in advance. Finally, W.V.O. Quine's underdetermination thesis establishes that any given set of evidence can support multiple conflicting ontologies. The chosen map is therefore always a paradigm choice or a political decision rather than an objective truth. Because of these absolute mathematical and philosophical limits, building a globally reliable, permanently action-authorizing ontology is structurally impossible. This graph visualizes the resulting deficit, known as the epistemic gap. The small bar on the left represents the actual epistemic warrant, or proven knowledge, the system possesses. The massive extending bar on the right represents the operational authority the system is permitted to exercise. The vast space between these two bars fills rapidly with unmanaged uncertainty, systemic error, and unlogged data transfers. The Bridge360 model defines this friction as leakage. When this unmanaged uncertainty accumulates and reaches critical mass, the system triggers what is known as an entropic blowout. In the real world, this blowout materializes as compounding misclassifications, institutional coercion, and irreversible automated actions executing at digital speed. Deploying an unchecked ontology does not contain operational chaos. It institutionalizes it, scaling localized temporary errors into permanent systemic collapse. This theoretical danger is actively deployed today. Palantir exemplifies the precise class of ontology-based operational systems utilized in critical government and military contexts. Under CEO Alex Karp, Palantir explicitly focuses on connecting software architecture directly to the exertion of state hard power. This architecture is heavily influenced by co-founder Peter Thiel's philosophy, which champions structural dominance and the deliberate suppression of competitive variance. Palantir's leverage stems from its ability to unify fragmented data into a central enterprise ontology, connect that data to AI logic, and securely write automated decisions back into live operational systems. This architecture represents the exact threat the Bridge360 model identifies. It transforms a selected, inherently biased conceptual map into an executable command surface for institutional and military action. Palantir grants its ontology absolute operational sovereignty before ever proving that the system can survive an entropic blowout. Probabilistic agentic systems do require explicit conceptual boundaries to function safely, but those boundaries cannot be treated as ultimate institutional authorities. The solution is a higher-order architecture called ontology governance, a framework that dictates exactly when, how, and if an ontology is allowed to guide action. The agent's ontology is surrounded by the Bridge360 meta-governance perimeter. Data hits bleed gates. Caveat vectors declares blind spots. Leakage accounting identifies the cost of incorrect classifications. Deterministic rollback ensures a route to reverse decisions. The ontology remains a temporary grammar, not absolute truth. Through these sequential gates, meta-governance successfully strips the ontology of its sovereignty, reducing it from a dangerous reality engine into a safely bounded tool. Frank Coyle's initial premise at UC Berkeley is correct. Unconstrained probabilistic AI agents absolutely require semantic guardrails to function without looping into chaos. But if those guardrails are left ungoverned, the ontology metastasizes into an unchecked, executable metaphysics. There is a vast difference between organizing information to understand a domain and permanently authorizing institutional action over it. Coyle's neurosymbolic engineering supplies the necessary semantic constraint. But the Bridge360 model supplies the critical admissibility governance. Ontology organizes the AI agent's map, but only strict meta-governance can dictate whether that map is ever allowed to become an action.